So before I wrap this up, I'd like to go over some of the do's and don'ts that you should follow when either writing your program or when debugging that will very much ease the debugging process. The first one is, do rewrite any code for which there exists a more efficient implementation. And what I like to do is before I start writing any code at all, I like to think through the algorithm that I will be using and what options I have in terms of algorithms and which one might be the best in my specific scenario. Looking at the runtime complexity and looking at the amount of memory that is used. But sometimes, as you're writing a program, even if you've thought about the implementation very thoroughly before actually starting implementation, before actually starting to write the code, sometimes you'll realize while you're programming that there is a more efficient way to do this, and you learn as you're coding. You learn more things about the problem that maybe you haven't noticed before. And so, if this means having to start over and start from scratch and try to approach the same problem in a different way, I highly recommend it because really you write code for two reasons. And one reason is to find the most efficient way of solving the problem at hand. And I'll talk about the other reason in a second, but because of this, if you can find a more efficient way to do it, I highly recommend taking that. And it'll, of course, ease your debugging process in the end because the algorithm will usually be more self-explanatory. And that brings me to my next point. Do use algorithms that account for special cases, because a lot of the times when people come to me with code that doesn't work, I will see that they used an algorithm that solved the problem, but that there are a lot of cases that aren't accounted for. And so what people will do to account for those special cases are to either try and catch them, which is, in my opinion, the ugly way of doing it, or they'll put a conditional before they execute the algorithm that checks if it's that special case. And an example of that might be if you're writing an algorithm that does something with a list, but if the list is empty, it would throw a null pointer exception or some sort of none error. And so what you do is you create a special case at the beginning. If the list is empty, do this. And of course, sometimes that's necessary, but I would only use it when necessary. And the reason I would do that is because, one, if there's a case in which you can use an algorithm that accounts for all special cases or more special cases, that's usually going to be a stronger algorithm, and it's usually going to be more effective in solving the problem, which, once again, that's one reason why we program. Now, the other reason why we program, or the way I like to think of it, the other reason why we program is for somebody such as either ourselves or another programmer, for them to be able to look at the code that we wrote, gain an understanding of how it works by looking at it, and use it as a foundation for future projects. Because if you write code that you're going to take nowhere, then it's like, well, I may have solved this task, but where am I going to go next? So I always like to think about where will my code be taken in the future, and does it look understandable to somebody who has a similar level of experience in programming that I do? And of course, if you have code that is readable, it will really, really help you a lot during your debugging process, even just understanding your own code and what it does. And part of that code being readable is using an algorithm that makes sense and that you don't have to think about special cases in which it won't work. Because a lot of the times, if you use an algorithm for which there are a lot of special cases in which it doesn't work, then you might not always think about all the special cases and you might miss one or two here or there, and then you'll run into more errors than if you just used a stronger implementation in the first place. Now, a couple of the don'ts, and I know I've stressed this already, and this is just a huge thing I see. Don't Google an error message or look for fixes before you actually debug yourself, because you're only wasting your own time. Your error is specific to your situation, and it might happen that somebody else had a similar sort of error that was specific to the same situation, but you don't know that. You know what your situation is, what your code does, and if you can find the error yourself without having to go and try to consult other sources and see if they apply to your scenario, um, then you don't risk bringing in code that doesn't work or fixes that won't help you. And that brings me to the next point. Don't copy fixes from the internet without understanding how they work first. Because if you copy code from the internet without understanding how it works, you're going to make it more difficult for yourself if that code that you copied doesn't apply to your scenario, or doesn't work correctly, or doesn't do what you think it's supposed to do. And then you'll end up having a bunch of stray code that is only making your program more confusing and more difficult to debug in the end. So that concludes this series on how to properly debug. And if you have any comments on things, maybe I didn't mention something that I could have mentioned, or maybe you have something you'd like to add, please, please, please post a comment. I'll definitely read through them and look at them and take them into consideration. Of course, programming is an ongoing learning process, really. I'm not claiming that I know everything, and I'm not claiming that this is necessarily the best way to debug. If you can think of a better way, please feel free to let me know. Also, if you have any questions, feel free to post your questions in the comments section, and I will also try to look at and respond to those. If you found this helpful and you want more videos, please let me know. Thank you for watching.